lab 2. In that set of questions, we had to create a point class. So within Java, let's create a new class called point. Just press finish, and the point class had to have an x coordinate. So that's private double x, and a y coordinate, private double y, and that's it. And create a constructor for that. So you go to source, insert code, and choose a constructor. Let's go for a constructor with 2 parameters, and also we can have a constructor with no parameters as well. But if you do that, then it's always a good idea to set the values of x and y. So we could either do x equals 0, y equals 0. That's one option. Or the other way to do it is to use the constructor that we've already come up with, and use this POI. Sorry, that's wrong. Just use this 0.0, 0.0, and that will call the constructor with 2 parameters. So if somebody asks for a default constructor, it will call the constructor that we've written with 2 parameters with 0, 0. Okay, then add the getters and setters. So this is all standard stuff, and I'll just add the getters and setters for both things, generate those, and I'll add a toString method and generate that. Now, because I'm going to use inheritance here, I want the toString method to be something that I can reuse. So instead of just taking the default, I'm going to write it so that it has x and y as, let's get this right, oops, making a bit of a mess of this, but it's going to have x and y as a pair of variables within brackets. And something else that we were asked to write as part of the example was an is equal to method. So that is public, and it returns a boolean whether whether we have something that is equal to or not. We'll do a little bit more on comparing objects later on in the course, but for now, equal to, well, what? Another point object, and that point object, we need to give it a name, so it's often a good idea to call it other. And then what we're going to do is we're going to compare the x and y coordinates. So you can do this all in one return statement, because what we can do is we can say this dot get x. We can test if that's the same as other dot get x, and so that's the first comparison, and we need the same thing for this dot get y being equal to other dot get y, and that whole thing, oh, that's okay, I'll just put a semicolon at the end, and that's the point class done. Alright, let's move on quite quickly, because now I want to do the circle class. The circle class is exactly the same as the point class, except it's got a radius added to it, and we can add some methods for area and circumference. So what gets added? A radius, which is going to be a double. I'm just going to call it R. You could call it radius if you wanted to. Oh, and one thing that I've missed out, of course, is extends point. And I have to make sure that circle is in the same package as point. And then when I do that, sometimes it usually comes up with an error, but let's give it a go. Source. Oh, it won't come up with an error because we have a default constructor for point. But let's just. Right. So I want to use. I want to have a constructor which sets the value of R, and I can choose which constructor I take from the superclass, and I'm going to choose the 2 parameter one. So you'll see there that super XY is chosen and XY and R are all passed over. Now you might want to change the order of these things. Let's just cut that out and we can put that at the end. Some people like that sort of thing. Why doesn't like it? No, that'll disappear in a while. So there's the constructor. I need to insert getter and setter for R. I need to write a method for the area. So that's public. It's going to return a double for the area. Get area. And I don't need to give it any parameters because the area is return. I'm still a little unsure why is that the legal start of type. I put a comma at the end. That's why the error was coming. Return, and it's pi r squared. Now to get pi, don't put in 3.14. Use math dot pi, a constant, times this dot get radius times this dot get radius. There we are. There's the area. And for the circumference, get circumference. Is that right? Circumference. I think that's right. And it's a similar. If I could spell, it would be a similar math.pi. So the circumference is pi times the diameter, or pi times 2 times r. So I can use this dot get r. Brilliant. So there's the area and the circumference, and I need to add a toString. So I'm going to insert code the toString. But I want to have, it's just got here circle R and just circle and the R. But I want to use the point from earlier. So I'm going to use super dot toString, and that will give us a point. And I could precede that with something like center equals plus super dot toString, and then I could have something like radius equals R, and that will do it. I'm trying to create a toString that could be used later on in the constructor for the cylinder. I'm just going to ignore the phone. Okay, so that's that one done. Now I'm going to create another class, and this time that's going to be a cylinder. And cylinder is going to extend the circle class. I need to create a constructor. The phone will stop in a moment. Insert code constructor. There we are. So it's, oh, what haven't I done? Stupidly, I was put off by the phone. So I haven't given it a height. So now I need to put in the constructor, and this time it'll ask us for the height. That's better. So now I've got the height x, y, and r. I can put in my getters and setters for the height. That's okay. And I can put in my toString, generate. But this time I'm going to use super dot toString, which will give me the center and the radius, and I can put plus height equals h. Oops, I could have used that. Might get rid of that bit. Okay, I also, the question asked us to override the area and add a new method for the volume. So I could insert code which overrides. If I go to override, I can choose which one I want to override. So I can choose area and generate that, and it will give us the correct signature. And what I want to do is I want to get the area. Now the area is 2 pi r times r plus h. So I can write that as 2.0 times math dot pi times this dot get r times open brackets, that's right, this dot get r plus this dot get h, and that should give me the area. That's the overridden method, and I want one for the volume. And the volume is pi r squared times h. Now pi r squared just happens to be the area of a circle, so I could, if you wanted to, use super dot get area and just multiply that by this dot get h, or you can write the whole thing out, it doesn't really matter. Now one thing you might notice from this is we haven't overridden from the, there's an error come up somewhere, that's okay, we haven't overridden from the circle class the get circumference. So you could, if you wanted to, make that into a private no, you could make it into a final method to stop it being overridden, but that's entirely up to you. And then in the main class, what can we do? We can do things like point a equals new point 3, 4, point b equals new point -1, 0, and we could print those out. A dot to string s out, b dot to string, yeah, just run that and see what happens. Need to compile, of course. And then there's the things there. One thing that we can do is I could make a new point C equals new point 3, 4, and I could test to see whether that, I should have checked this beforehand, but let's do an A dot is equal to C. Let's see what happens with that, and let's also test, oops, so A equals C, and let's see what we get with that. The first one says true, so is equal to is true because that's the method that we wrote, and that tested whether the x coordinate and the y coordinate were the same for both points. The second of those, A is equal to C, actually tests whether to see they're the same object, and they're not, they're different objects, they're stored in a different place in memory. So that's a good example of where is equal to is different to just testing equality. Then we can make some circles. Circle C1 equals new circle, and I think I did the x and the y first, so I could do 0, 0, 3. So that means it's got a radius of 3. And if I do s out C1 dot to string s out C1 dot get area and s out C1 dot get circumference, and run that, we should find that the area is 9 times pi, which is about right, and the circumference is that, which seems about right as well. and then you can do similarly with the a cylinder. CY equals new cylinder, and I think the height came first, so let's give it a 1.0. Then it was the center, and then finally the radius 2.0. Do S out CY dot to string. We could see that, and we could also see S out CY dot get volume, for example, and run that. Okay, now I'm just going to go on a little bit further and see what happens if we wanted to create an array of these objects. We could create it with point PTS equals new point 5, for example. So that creates a new array of 5 point objects. And what we can do is we can say PTS 0 equals A, sets the first one, PTS 1 equals B, that's the second one, PTS 2, 2 equals, and now we can add a circle, PTS 3 equals, what was the cylinder called, CY, and PTS 4 equals, I think the last point was C. And now I can do a little for int I equals 0, I is less than the length of PTS, which is PTS dot length I plus plus, and within that loop, let's do it properly, put some curly braces there and there. So within the loop I can have S out what was it, PTS I dot to string, and let's see what happens when we run that. We should find that the 5 things that we've put in are these 5 things here. So the first one was a point, the next one was a point, the next one was a circle, next one was a cylinder, and the next one was a point. So using inheritance we can create arrays of a superclass and put items of a subclass in them, which is really useful for later on, where we can have specialism within the same array. And that's just about that, I think. Hope you enjoyed that. Join us next week for another thrilling episode. Goodbye.